I have a chat line where you definitely say, if you like a full version of a specialized chat line, because like upload
Sure, yeah, actually.
basically only have it hard and with the active learning in the sense of yeah, that is the that's the thing left in the general.
Okay, let's start. At the beginning, I will quick.
Yeah, sorry about the disruption. Please go ahead, Michael.
Yeah. Actually, my name is Michael Khlystun. I'm HPC System Administrator at Hofstra University. And also, I'm NVIDIA Ambassador at Hofstra University, and I'm responsible for HPC cluster here. And today, I'm talking about how we can use HPC cluster for your scientific research. My presentation divided into several parts. Here you can see 6 parts, but there are 2 main parts. First of all, it's a theoretical part, and the second is the practical part. For understanding what HPC is, let's compare HPC with classic virtual machines. Classic virtual machines have several advantages and disadvantages. First of all, it's a full isolation between workloads, because you can create a virtual machine with a different operating system, with a different version of kernel, and you have full isolation. Also, virtual machines are suitable for long-term services. You can run your services 24/7 and provide it for your users. And also, usually you will have administrator or root privileges on your virtual machine, so you can install or reconfigure your virtual machine as you wish. But there are some disadvantages of that. First of all, and it's most significant for us, it's a limitation of computational resources. I have never seen a virtual machine with more than 100 CPUs. It's hardly ever. It's possible, but hardly ever. The second issue, if you have root privileges on your virtual machine, you're responsible for maintenance of this virtual machine. You have to update software, you have to solve all issues with that. So it's your responsibilities. And the second significant issue is that it's difficult to provide GPU resources inside the virtual machine. It's possible there are techniques to pass through physical devices like GPU video cards inside the virtual machine. But in this case, you lose the main advantages of virtual machine. It's isolation between software and hardware. You can't migrate your virtual machine across hypervisors. So it's like a bare metal. As I mentioned before, the main constraints of virtual machine is limitation of CPU and RAM and input-output throttling. Just in case, I checked Google Cloud, and the biggest virtual machine which you can create there, it's 360 CPUs. That's all you can create bigger. Talking about HPC. HPC provides huge computational resources. For example, our cluster has 1,000 CPUs and several terabytes RAM, and we have about 40 GPUs on the cluster. It's 20 A100 and 20 H100 GPUs. A100 it's Ampere architecture. H100 it's next generation of GPUs. The next significant advantages of HPC cluster is variety pre-installed software. Since the cluster is a multi-user environment, all software already installed by system administrator on the cluster. so you don't have to spend time to install software for the cluster. And it's a huge scientific community. A lot of university or computational centers have their community and they use clusters, HPC clusters for their research. But there are disadvantages of this approach. First of all, it's a shared environment. It means I can create environment comfortable only for you because comfortable for your environment might be not comfortable for another user. So it's always compromise. The second disadvantage is it's more complex architecture of that, and it requires a minimum level of knowledge how to use it. Imagine we have a server with 16 CPUs, and we can create 4 virtual machines with 4 CPUs per virtual machine. And the graph will be like that. It's just constant usage resources. But if we talk about HPC, HPC operates tasks or job. In this context, it's the same. I will use both words. And we can see that HPC provides a lot of computational resources in short-term period. It might be hours, days, but hardly ever longer. So we can consume all 16 CPUs in this example for your task, but in short period of time, not just a couple of months. And if we imagine that there are several tasks on a cluster, the graph would be like that. For first period of time, all resources are used by the first task. After that, the first task finished and the next task uses all resources. But it's not necessary using all resources. For example, at the end of the graph, we can see 2 tasks which are used to have all resources of the cluster. And here is a top of 500 supercomputers in the world. Actually, I got 3, top 3, not all 500. And El Capitan, Frontier, and Aurora. And we can see that all of them use regular CPUs like AMD EPIC 24 cores, AMD EPIC 64 cores, Intel Xeon, and these supercomputers, it's the most powerful computers in the world. And the question is how they can use the regular CPUs and have so powerful computational resources. The answer is simple. They use a cluster approach. Imagine we need 1,000 CPUs for a task. And there are 2 ways, 2 approaches how we can do that. The classic approach, we buy or build or create one server with 1,000 CPU cores. Okay, it's possible, but the problem is the prices is not linear. For example, if we want to buy a CPU with 10 cores, the price would be $10. If we want to buy CPU with 100 cores, the price might be $250. But if we want to buy a CPU with 1,000 cores, the price might be $5,000. So it's not linear. The second issue is that imagine we need to make a maintenance of our server. For example, replace some hardware parts or update software or firmware. It means the system administrator will shut down the server and we have a 100% downtime. So we can use this cluster. Let's take a look to the second approach, cluster approach. We use 10 nodes with 100 CPUs, of course. In this case, oh, by the way, let's go back to the previous one. Imagine we need to upgrade our cluster and run the task for 1,100 CPUs. What we need to do? We need to decommission on all servers and buy a new one, or we have to upgrade it. It's might be not easy. But in the cluster approach, it's pretty easy. We just buy plus one node and add it to the cluster, and we can scale it horizontally. So it's not a problem. Also, maintenance is pretty easy. We can shut down one node out of 10, and we have 10 nodes available in the cluster, so the end users usually don't notice that because they can run their task in the rest of the cluster. But cluster approach requires a good intercluster network. It means we have to connect nodes in the cluster with each other. In our cluster, we use InfiniBand network with 20 gigabits per second. It's a pretty good low latency, high-speed network, and it's enough for our task, and it's a common approach for many top 500 clusters as well. And the second one, yeah.
Basic question. Is it correct to think of a node as a sort of an individual computer with its own system, its own memory?
Yes, correct. I can use word node, server as the same as synonyms in this context.
Here we have one computer that is super powerful on one side, and the other we have 10 computers. They're 10 times lower, so to speak.
Yeah, using regular components, not so high, expensive.
Right.
That's correct. Thank you.
The difference is that you cluster, clusters these machines. In this case, these machines are not, they are really on top of that fact to be controlled. Right.
Yeah.
Right. If you have the classic approach, you would be necessarily
Yeah, I
have a computer with just one computer.
Yeah.
Yes. And using the cluster approach, we have to have a shared storage because all nodes must have access to your data because we don't know which one will process it. And the third point is that we have to use specific approaches to spread our task across all nodes of the cluster. I will cover it in the next workshops, not on this, because it's a huge topic. It's not simple. Okay, let's take a look at the schema of the cluster. Cluster, it's a set of multiple nodes. And we can see three groups of nodes on the cluster. First of all, it's logging nodes, storage nodes, and compute nodes.
Sorry, what's the head node?
Head node, it's a special type of node which control all cluster. Communication with it, it's for administration purposes.
The head node is what runs the scheduler. It's an administrative.
Oh, it runs Slurm.
Yeah.
Okay.
Yes, correct.
Slurm is running everywhere, but it's the master thing that works.
Yeah, it's like a head of all cluster.
Gotcha.
Yeah. So it's called head node. And login node is an entry point for users. we have two login nodes, login 1 and login 2. You can use both of them, and as I mentioned before, we use two login nodes because I can switch on one of them for maintenance purposes, and if you can connect to one login node, just try to connect to another one. If you are in campus, you can connect directly to login nodes. If you off campus, you have to use VPN. If you are faculty, you can ask ITS to provide VPN for you. If you are a student, you can ask Alex, computer science department, to provide VPN for you. And login nodes provide SSH access, and there is additional option like a web portal. You can use your browser to connect through the web portal, and after that you can get a login shell as a login nodes, or you can run some kind of interactive application in your browser in the cluster. Yeah, you don't have direct SSH access to compute nodes. You can access only login nodes, and you use login nodes as your control plane. So you run your task on login nodes. I mean, you submit your task on login nodes. But after that, the scheduler will choose suitable or available compute nodes and run it on the compute nodes. You don't have direct access to storage nodes, but storage nodes provide shared storage for your project folders. One important moment: there is no internet access from compute nodes. Oh, by the way, I will use words compute nodes, GPUs nodes. It's the same in our case because all our compute nodes has a GPU, but in the big clusters might be two different categories, but it's not our case. So if you need to download data set or download your code, just git clone from GitHub, you have to do that on login nodes because compute nodes only for computational tasks. It's not for downloading files. Okay, scheduler. There are two ways how you can run your task on the cluster. Yeah, first of all, Slurm. It's a task-based approach. It means you can just run your application like on your laptop. You have to submit a task for scheduler, and after that, the scheduler will choose available compute node for your task and launch it. There are two types of task: srun and sbatch. The main difference of that is srun is an interactive task. It means when you run a task and you are going to interact with this task. For example, enter some data or control it. Usually it might be useful for debug process or some development process. But for huge computational task, sbatch approach is a common way. It's just submit your task and next day get results. So submit it for me about that. For srun, you have to specify all options on the command line. Like in this example, using sbatch, usually we use a file where I describe all settings. I will show example next slides. Also, you need to know that there is a quality of services on the cluster. You can think about that like lines of view for tasks in the cluster. The difference between QoS is max time for your task. As I mentioned before, HPC is not about long-term task as a service. No, the longest task. In this example, it's 2 weeks. You can run the task longer than 2 weeks. And to run this task, you have to use QoS with name long double X. But you can ask me why we can't use for every task this QoS. Yes, you can, but it means your task will have the lowest priority across all tasks in the cluster. So the good reason to understand time, how many time you need for your task. Normal QoS is a default QoS, and it provides 1 hour task. Usually it's enough for many tasks, for execution many tasks. And it has a normal priority. The highest priority is burst. It's for small short tasks. You can think about it like a fast track. If you have a small task and you want to run as soon as possible, you can use burst QoS. But by default, it's normal. Okay. That's the most interesting point for you, how you can bring your own software on the cluster. There are 4 ways how you can do that. First of all, it's a Python virtual environment. The second is using modular system on the cluster. The third approach is obtained. And the last way, you can ask me to install the software. Yeah, it's possible as well, because sometimes it's not trivial. For example, I installed MATLAB on the cluster, and it's not a case for first the approaches. Let's take a look at Python virtual environment. It's the most common way. It's not cluster specific. If you're familiar with Python, you know how to do that. You just create a virtual environment for your project, and using pip install, you can install all necessary libraries and packages inside your virtual environment. That's all. You don't need some admin or root privileges for that. You can manage your list of projects or Python packages, and it provides isolation across other users. So it's a good basic approach for Python projects. Yeah, here it's examples how you can create your Python environment. You can specify path for your project. It's best practices, especially if you work in a group under the one project. You can create one virtual environment for all members of your project, and store your virtual environment not on your home directory, but in the project directory. Yeah.
Is Conda the preferred way to create a virtual environment? Because I just use Python's VM module.
Yes, it's possible as well.
Because Conda creates a lot of files. It like really fills the file system very fast.
Yes, just up to you.
But what's your stance as the administrator?
Yeah, I think Python might be better because it's just built-in way to do that.
Yeah, you don't need Conda.
Yeah, you don't need to have a Conda. But yeah, you can use it as well. And after creating your virtual environment, you need to activate it, because you can have several virtual environments, and if you want to run pip install after that, you need to specify in which virtual environment you want to install your packages. So you need to activate it. Also, if you want to use Jupyter Labs, our cluster provides Jupyter Labs across WebUI interface, you need to install 2 additional packages, IPython and IPython kernel, and run the last command just to make it available on the Jupyter Labs. In the previous workshop, I did it for you, and who was there, you didn't do that because it was made by me. Okay, module system. We use a SPAC. SPAC is software package system for HPC clusters. It's environment modules, and it provides not only Python applications. You can use a lot of different applications. Yeah, the problem is the cluster is a multi-user environment, so module system allows you to have a different version of libraries or software on the cluster, and you can switch across that because different users want to have different version of the software. And here it's a minimal list of the common how to use. First of all, module list shows you all modules which are already loaded in your environment. And if you want to use all available packages, you can run module available. And I recommend using pipe grep just to filter just software because it's several scripts of packages, so it's difficult to find what you want. And when you find your necessary package, you can load it into the command module load. And when you finish work with it, you can just run module unload. Pretty simple and logical. And the last way is using Obtainer. It's a containerization system for HPC. And you can run application inside containers. It's very close with Docker containerization system who works with Docker. It's very close. You can convert Docker images into Obtainer images and run it. And yeah, actually that's all. It's pretty simple system. Yeah. You can use Obtainer run and pass for container to run it. You can use Obtainer pool to download container. But as I mentioned before, you have to do that on the login nodes. I mean Obtainer pool. Because there is no internet access on compute nodes. Yes.
Do we have privileges to install software on the cluster?
It depends on.
So when you say you, it really is like a few people who have a
Yes, for example, you can run Obtainer pool and download Obtainer image into your project directory or into your home directory and execute it. So yes, you can install.
So it would run just locally for me.
Yes, it doesn't require root privileges.
Can you give me an example? Because you already have R, MATLAB, Python installed. So would it be like a specialized software? Like, can you give me a use case for when we would do something like this?
For example, I use Obtainer to run LLMs using inference server modular max or VLLM.
How about that? We have access to the GPU cloud, which is just like Java, but it provides container images that already have a lot of software pre-installed by NVIDIA optimized just for the hardware we have. So that anyone can install software through Obtainer, anyone with access to the cluster. it's another way. If you asked for some examples, let's say you're using TensorFlow or PyTorch, and you have the whole stack that you want to use, and you don't want to have to, figure out how to, it might be already installed in cluster, but often there are some very specific, version dependencies for a certain stack. And you don't want to have to run around getting it working yourself. You find a container image where everything is already there, and you might find a tutorial that says, I'll use this one for Docker, or an NVIDIA tutorial that says use this one for the MVC. And it gives you kind of a turnkey solution to a software deployment.
Yes, thank you, Alex. Yes.
What components can you use?
Yes. It's also possible. I didn't mention this way, but of course you can bring your source code and compile it using a lot of compilers. We have a GCC compiler as well. Yeah, but usually it's the most difficult way, and I just didn't mention about that. But yeah, you can do that.
So the reason I'm asking is because I have a lot of old code, like really old code, like Fortran. So I use G Fortran.
I think yes.
Speed, but
I think yes, we can check it in the practical part. I think I installed it using modular system. I mean Fortran compiler. So I think yeah, it's available. Okay, couple of words about storage. We use HP parallel file system storage, and there are two places where you can store your files or data. First of all, it's your project directory. All project directories are located in the /fs1/projects/name of your project and your home directory. The difference is home directory has a small disk space. Usually it's about 50 gigabytes, and it's only available for you. If you work in a group for your project, it's better to store on project directory, like a virtual environment, data sets, results, and your home directory is just for configuration or some your private files. Yeah, one important moment. We have hardware and software reservation on storage. It means we can lose one physical server with all drives with your data, and we don't lose your data. We have application, we can restore it. But if you occasionally delete your data or changed it, we can roll back it. We don't have backups, so it's your responsibility. Okay, how we can bring data on the cluster? There are two ways how we can do that. It's a push approach and pull approach. Push approach, it means when we copy data from, for example, our laptop to the login nodes, we can use SSH or SCP or rsync. It's better to use tar to combine all files into one if you need to copy a lot of files. It would be better. Or you can use a web UI interface and download and upload files using that. But it works for small files like several megabytes. It's not a good way to put 10 gigs file across web UI interface. The second approach is a pull approach. It means you run, for example, git clone or hugging face we download on login nodes, and login node will pull your data on the storage. So it's much better for big files, for huge data sets. Okay. And now just the practical part. All examples in this practical part I stored in the directory /fs1/shared/lunch-and-learn/December 03. If you have laptops and you want to get access to the files, feel free to take temporal accounts. Yes.
Question?
Yeah, I sure want to end with it for the password.
Oh, I guess we have.
We cut them?
Yeah, it's the same thing. I just cut them.
There's some duplicates. Right?
There's some duplicates.
Yeah, so we. I don't have computers, so we can. Yeah. They don't just pass along, right?
Yeah.
Okay, this simple example of sbatch file, and we can divide sbatch file into two parts. First of all, it's a head where we specify instruction for scheduler. First of all, we want to specify the name of task or job. It's not necessary, but it makes sense to give some reasonable name for that. You can use just job name task1, task3, task4, but it's a bad practice.
You might want to give us a little time because I think we're passing around the account, the temporary account.
Yeah, sure. Do you need some assistance with it? Or just time?
Even I think so. For example, if I'm using the same way that we used before, so I would want to go into a shell.
Yes.
Right. Because last time we did Jupyter Lab.
Yes.
Right. And then from there, then we navigate.
Yeah, you can use cd command like a change directory, and after that you can use cat just to print example, and you need to specify amount of resources for your task. It's very important for scheduler to allocate your task on the right node.
So so right now, as example also that when I go into that directory,
Yes.
right? So cat is what's going to type out what the S example was fast.
Yes, correct. Yes. And in this example, we said we need one node on the cluster and with 4 CPUs. Means for our task will be available 4 CPUs and 128 gigs memory. And I set QoS as a normal and max time for execution my task 30 minutes. And the last 2 lines, it's output for errors and regular output. I use internal variables like x and j just to store results in the format like job name underscore job ID.
So when I look at the that one that you have all of that, and then you have your code.
Yes. The second part of the sbatch is your code. You can write code inside the sbatch file, or you can just specify files in your code like Python code or C++ code, or even you can run Obtainer as well.
Right, so as part of the file, you have the, basically like the creation of the allotment of resources and time and the
And
script, for
payload,
example.
yes.
Yeah.
And after submission your task, we can use command sq to check the status of your task. If you use sq without any option, it will list all tasks for all users of the cluster. It might be a huge print, it's not convenient. So we can use -u and use this special word to show all tasks, especially for you, for your user. Also, after submission your task, you can see a job ID. It's a number of your task, so you can check status of your task using this number, just sq dash job and using job ID. But in practice, I prefer use just sq pipe grep and use job ID because it's more convenient. Just remember all options with sq, how to write it. Yes.
So I know this, it's silly, but when I just ran the S batch, sample one S batch,
Yes.
and I submitted the batch and I look SQ and I think it's done because it was very fast.
Yes. We can show the next example with a special delay. Yeah.
Output in the logs. There's a folder called logs.
Oh, I see. There's no output. Like this is printing estimate my estimation of pi.
Yes.
And I don't know where it went.
In logs. There's a folder logs.
Yeah, check the folder logs and
Got it.
yeah. That is why it's a non-interactive approach. When you just submitted your task and next day you check results. That's all. And one important case, if you want to stop your task, you can use as cancel and job ID. Don't worry if you miss out job ID, you can't cancel job for another user, only your task you can stop. Yes, and in example 3, I added delay just to take much more time for execution. Okay, the last part, how to get support if you need some help with the cluster. You can write me email. You can join a Discord server. Here's the link. And there is a chat bot in the Discord. It's LLM AI model. And actually, you can try use it because it's not just LLM like ChatGPT. It's LLM which answers specifically about a cluster. So they know about a cluster and can provide more correct answers than just ChatGPT.
So is that just trained on our website? Like how does it know? I mean, I guess that whenever I do a specialized chatbot, I just give it my textbook.
Yeah.
Did you do something fancy other than give it our website?
Yes, that's a good question. This chatbot uses RAG technology. It means retriever augmented technology, and it's a LLM model. But when you ask some question before that, chatbot finds the relevant information inside our vector database, which was built based on knowledge base for a cluster using a Confluence, actually. Yeah, and it's a good approach. We can build these chatbots for some faculty and provide information specifically about this faculty, about questions in their knowledge base. It's not ideal, but yeah, we can use it. Okay, as a summary, we discussed how to bring new software on the cluster. We can use Python virtual environment. We can use Uptainer. We can use module system. You can compile your source code as well. You can ask me if you need to install. We discussed how to copy your data. You can just use SCP or rsync to push your data of the login nodes on the storage, or you can use full approach, just git clone or Hugging Face download to download datasets. We discussed how to run your program. We can use srun if you need interactive approach, and you can use sbatch if you need a non-interactive task. And we discussed how to get help. Thank you for your attention, and yeah, it's all about slides. I can show just several examples. I need to switch my screen, just a second. Done. Oh. Yeah. I prefer using command line, but you can use the web interface. So yeah, I think it's better to show using web interface. What in this case I didn't see that. Okay. Yeah, first of all, we need to use open an ood.start.hofstra.edu address to connect to the cluster.
I can still SSH into the machine.
Yes, if you have a cluster account, you can use SSH if well. Yeah.
So, are you only allowed to log into this if you have a Star account?
Yes, yes.
Do you have one of these temporary?
Oh, no, I do not.
Yeah.
Thank you.
I think any student who has an account on the Linux system.
No.
So. No, I think, so the same system is used, but no, you still need to request an account.
Oh, I see.
Okay, whether, if you are a faculty or a student, then you're already in the system so that we can more quickly create an account. But it's,
The separate.
yeah, so
Okay.
when an account is created on Hofstra, it's also creating like, it's creating an entry in Slurm, it's creating a folder for you. So anyone with a Linux account could log in, but they wouldn't be able to actually run jobs.
Got it.
So it's kind of useless.
Got it.
Yeah.
Yeah,
Students would need it. So.
Yeah.
it means access to the cluster provides based on a project approach. So it's not just get access to the cluster. The access provides for some project. If you are a student, you need a faculty sponsor who will say, yes, my student works on this project, please create the account. Or for some educational purposes, for example, if you use a cluster in your class, you can ask me to create 20 accounts for your users for the class. That's all. Yeah, if you are faculty, it's not a problem.
So if we wanted to do like a demo in a classroom, would we use these? If we wanted to just do it one time?
Yes, if it's just one-time demo, it's better to create one-time accounts. If you need the cluster during the whole semester, it's better to create a permanent accounts.
We can, like we've had other classes where they just request access for the entire class. And they might not use it, every day in the semester, but they may use it for some assignments. That's not the problem. We can move to it.
Are those accounts related to different services? So, like the number of jobs that you can run?
By default, we have everything the same. We can, like, we can assign, it's really based, so for classes, for instance, we create a project specific class, and everyone in that class, they will all using, let's say we actually have a research convention. That means it was, and all students are using it at the same time, they would be splitting up the resources allocated for that project. Yeah, so, and if we, there are cases where we have like faculty or students that are actually working on certain things, like this research project and also access for a class. When you submit a job, you specify which project it's called a student account, which project is for. And that way, let's say you enroll students for class, but the research you get, the section title. But when the research you submitted and you don't get the strengths.
Yeah, it's all necessary because NSF provides grant for the cluster, and we have to report NFS at the end of the year about using the cluster, about utilization of the cluster, about projects on the cluster. So we need to this information to create
There's also a way that we can, if there's a research project that needs priority or something, we have the ability to.
And then, when you show like can you show at some point, the job, like a long job, you also did one, is that correct? When we show that the types of jobs, like the long one that runs for 2 weeks, can you show that there's a limit of one?
yes.
So if I submit one of those jobs, can I still submit quick jobs?
Yes.
Okay.
Yes, because HQS has different status. Yes.
So like, if I need something run for 2 weeks, that will not block me my ability to run quick jobs.
Yes, correct. And all of them with protection, just not to utilize whole cluster under one user.
Your resources require you have to look for, a window of availability, and there are plenty less. So, it's, the system uses, something known as, multi-factor scheduling, system, and there are multiple factors. It looks at fair share, which is like, if you are a user that, has used the cluster a lot in, let's say, the past few weeks, your priority is so low if someone has used it. But then it also looks at other things like, your, entitlements, for the account. So, if you are, let's say,
Yes.
Is this Zoom meeting available anywhere?
It will be posted afterwards.
Posted where on?
On
It's
YouTube.
been given secret.
Oh, okay.
And if you go to the Star HPC site, there's a link to it.
Okay.
That one person.
That's this one, right?
uh,
Or
No, it's just
That
Star.
one person, has these
Yeah.
resources.
Yeah.
So it's not like
came in from here.
But it's not simple, at the end of the day, if there's actually any understand business issues, financial issues, they're not going to trust the business because it's a system to ensure that it's verified.
Okay, let's move on. Using the web UI interface, as I mentioned before, we can upload and download files, but of course you can use a command line for that, like SCP or rsync. But web UI is just fast start.
Use SMTP.
No, we don't have SFTP.
SFTP service.
Yeah, SCP. Or you can use using SSH tunnel for that. Yeah.
SFTP.
Yeah, that's what I.
SFTP is compatible with us.
Yeah.
Is using
Okay. Also,
I actually use both.
you can have console access here using web interface, and for example, just check available software. Yeah, the list is pretty huge. And let's try to find yeah, we have some Fortran, but I'm not sure if it's compiler or not. But yeah, don't worry, we can install a Fortran compiler if it's necessary. Yeah, I guess it's a GCC compiler for Fortran.
So I have a question, maybe not related, but so this is way back. Because I'm I have code that uses NPI. It's an NPI compatible. Yeah, you can install it and it's inside. But you can't use it.
Instead of my Hofstra campus.
Yes, you will have to go to the Star HPC and apply
Yes,
for
it
permission.
has to be, your application that you submit has to support an NPI. Okay, an NPI.
So I'll give you the user scenario, so I know it's a library, so I create code and I insert some commands that are, calling the library.
Yeah.
So when I compile the code, the library needs to be like linked.
Yes.
And so I generate my SQL code, like that code. And then when I run it, I can also run it using like all sorts of different methods, right? Like you were showing. So when I run it using
Watch, yes.
Yeah,
And
yeah.
it is the 5.7
So you could say, for example, I want to run this in like 10 nodes, or something like that. You can do that, right?
Yeah, it still has to be submitted through Storm. The Storm is what's allocated to resources. But you can, as long as you have resources, you can do it. I mean, it doesn't matter, you can actually do it through S1 or S-Dash. S-Dash is just a shell script, and then we you're gonna see the output. Yeah. And that's run is more, it's interactive kind of like, you can actually start that, the rest running, you're trying to pick it, like that's a stage. So it's just, Slurm is just for getting you the resource time. Okay, the time slots, like reservations did it.
So I could run the same code using 10 nodes, using 100 nodes, or.
Well, we don't have, but if we did.
Okay, for example, let's run example 3. There is delay. I added it specially just to make a task longer. Just and oh yeah, actually it's a good point. Okay.
Oh yeah, normal queue.
Yes. Yeah. So. Oh, I can change from this user. Okay.
Now I feel better. It's not just my live demo that has troubles.
I have a lot of.
Okay, yeah.
Take a video, even if you plan on doing it live.
Take a video first, yeah.
Yeah.
Something will go wrong.
It's practically guaranteed.
Okay, I submitted my task and I get the job ID.
Mhm.
After that, I can do something like.
Oh, it's done, I guess.
Too fast. Okay, let's check. Maybe it's done. Okay. Still sample 2. It doesn't matter because grep user just. Oh, I guess I know. I know the reason of that. Just a second. Yeah, because I need to this one. Yeah. We can see our task in the queue and in status run. And example, we can cancel it. But yeah, in this case, we need to be sure about numbers. And one more thing. In previous examples, I didn't specify GPU as a resource, but if you want to use a GPU inside your task, you need to specify this resource. And we can specify type of GPU because actually we have 3 types of GPU, A30, A100, and H100. but there are only two physical A30, so it's just for development purposes, not for training or educational tasks.
Question.
Yes.
Is there a way to specify the G-res such that you can get either A100 or an H100?
Yes, you can
How do you
use.
write that? This
Yes.
is just A100.
Yes, just a second. I will show. But it's a little bit tricky because you can remove this one.
Probably the easiest way is to just specify the nodes that you want.
It's yes, you can do that, but it's not the best way as well because this node might be occupied, for example, or it might be in maintenance.
You can give a range of nodes and it.
Yeah.
Yeah, so you have to know hardware specification of each node and maintains it. You can use this specification, just the GPU and number, but
Oh, I see. But I don't want the A30.
yes, you can get A30. In this case.
So it's tricky, all right.
Yes, right.
If you do specify GPU 1 through 7 in brackets.
Yeah.
It goes to
So that's
and all of those have either A100s or H100s.
so that's specifying the nodes.
Yes.
Yeah.
CN01 is the only one.
Yep.
Yes, right.
So Michael, if you were gonna do this for like a class, which GPU it has the most, which one do you use?
We have about 20 A100 and 20 H100. So you can use any of them. And actually for class purposes, I thought about split GPUs because A100 and H100 support MIG technology, and it allows for us to split GPU into eight virtual sub pieces. Yeah. So in this case, we can have a lot of little bit small GPUs, but for classes, I guess it's enough.
How hard or easy is that?
We need to try to do that.
We've done it only once or twice as we get it.
Yeah.
And it affects the entire node, so we have to start it. We honestly was one of the selling points when we were getting the system that everyone was used it, and then we went to the 80 national labs and they were like, don't bother. We talked around, most people said it's nice and very good practice. So we have to manage it, but it is.
Yeah, the problem with it is manual options. We have to reconfigure GPU every time for that. It's not automatically, but yeah. If we have a high demand for GPUs, especially in one time for two different classes, maybe it's next step for us. Okay. Actually, I think that's all that I want to show for the presentation.
Okay, thank you very much, Michael.
Always happen. And yeah, I can try to show, for example, AI bot, for example.
Sir, I do have one more question about the cluster.
Yes.
So it seems like we only have 100 terabytes in total. If I have a data set that's like 20, 30 terabytes, is there any way to get it on there?
Do you mean about RAM or disk space?
Disk space. Let's say 50 terabytes. I mean, I don't have it, but like some of our friends in astronomy have huge amounts of data.
Yeah, capacity of our storage is 100 terabytes.
Yeah, but if one person uses 30, you guys are not going to be very happy with that.
Yeah, it's a good question. Actually,
it's one of the reasons that when you first signed up, we asked what are your storage requirements?
Okay.
Because if you have a lot of storage, you have to work with Michael to make sure that we can accommodate it.
I see. But like if we want to do big data, right?
The cluster is built to support that, but obviously not everyone can have 30 terabytes of data. So you have to work with Michael to coordinate.
All right.
It can be done, but you just have to work.
Yeah, correct.
Any possibility to expand the storage?
Yes.
Make a nice donation, or work on a grant proposal. We can
Yeah.
expand it.
You have space?
First identify what the requirements are.
Yeah.
Yeah.
To take a look at.
That is why I thought about a cluster approach, so we can
Yeah,
add
we can
just node into our storage cluster and just expand it.
One thing we do have with the Graphical space, the existing, the system we have,
Yeah.
when we bought it explicitly so we could expand it, and then it's HPE hardware running an IBM storage product, and then we went to expand it and we were told, oh, contract between IBM and HPE, it expired and they're going back and forth negotiating terms. So what we did instead, under the license we had, you can increase the capacity per node without relicensing. So that's what we did. We swapped out hard drives. We have the ability to add additional physical drives, but it still costs money. So yes, we have the capacity to do so.
Gotcha. Just not new nodes, but you can add stuff to it.
Storage request.
Yeah.
You can identify what the need is.
Okay.
The other thing is, it's made very clear from the beginning that we're not agreeing to store unlimited amounts of data.
Of course.
Storing some of that's up to the faculty to pick care of.
No, but I'm just saying, like, if I have
I
a,
understand what you're saying, just going a step further, saying, you don't have any obligation to store data.
sure,
It's a warehouse.
sure. I agree with that.
You could use like.
I mean, I'm thinking about scratch space. Like we load this data, we do the work, and then we remove it.
Yeah.
If you have the same problem with the capacity of the system, if you're not in a position to tell some department that they can allocate
Yeah.
a cluster on a regular basis.
Yeah. Of course, no, I'm just saying
Within the confines that we can.
within a short amount of time, is it possible to get a ton of storage and then delete it? Like a scratch, but
Sure, the answer is yes. Just make
Well,
more.
that's my consistency.
Yeah, I think we can close official part
Yeah.
today.
Okay.
Yeah, and close. Yeah, if you have any questions about the cluster, you can ask me.